Hello everyone. So what I have here for you today is a torch. Now many of you know how to make a torch simply by watching a DIY video where they do not mention the electrical aspects covered. But today I will show you what electrical parameters to be considered while designing a torch circuit. The first is the number of LEDs. For mine I have considered 6 for a nominal brightness, as you can see. Next we need to decide the power source. For my purpose I used a simple 9 volt battery which delivers a 500 mAh energy. However, let us see if the LEDs comply with my decision of 500 mAh energy limit. For this we need to do some math work, heavy math work. So here is the heavy math work. The heavy math work includes the first step of considering 6 5mm LEDs of rating 3.7 volts 20 milliampere. Now the net voltage becomes 3.7 volts at 120 milliampere, which is then the voltage is increased by 0.1 volt and the current is decreased by 10 milliampere, considering the overall power to be nearly the same. The next step includes the supply. Now I've already discussed about the supply. Now the next step would be the current limits. Now here comes the experimental feature. With lab bench power supply, I have headed for a 3.8 volt current limiting resistance to be 0 and I3 which is IS which is equals to 110 milliampere with 6 LEDs of ESR nearly 0. So considering that, we have got 110 milliampere, which is according to the plan, because we considered 20 milliampere at the start and we are considering for the 100 milliampere at a 3.7 volt 3.8 volt limiting. Now the other experiment reading gives us that series voltage is 9 volt and the resistance is as such 0 and the series current is 540 milliampere, which is way above 500 milliampere. So the battery will drain even faster with 6 LEDs and ESR is nearly 0. So drain is less than 1 hour, which is undesirable. So we add a current limiting resistor at 9 volts. So the equation is basically the Ohm's law. In there we have the potential difference, like 9 minus 3.8 divided by the current gives the resistance, and we get the resistance as 47.47, which is nearly equal to 50 ohms. Now considering for 50 ohms, we recalculate the current interchanging R and I positions, and what we end up with is 104 milliampere, which is the base load current of our torch. The current is then equated with the time, and accordingly the time of operation is then found out to be 4.807 hours. Now it's nearly 4.81 hours, and the second last step, which is for the number of batteries and wattage, is count of 2. I'm considering an extra battery which will give me a net milliampere hour of 1000, and the time of operation then increases to 9.62 hours, which is more than enough for an emergency operation. Now the next thing I would talk about is the loading resistor, which loading resistor basically the current limiting resistor. Always you can see in market they ask for the wattage. So the wattage is calculated by the I squared R. Through the calculation we get nearly 0.5 watt, and the resistance is around 50 ohms. So I had 100 ohms and we just got it parallel with a 0.5 watt, and the load power is derived from the voltage times current equation, which comes out to be 395 milliwatts.